Hey guys, welcome back to Chemistry TV. So we're going to look at what collision theory and reaction rates. After this, we're going to look at what the Arrhenius theory and the what activation energy. Then we're going to look at what the various calculation. So you really want to stick to the end of this video. I will appreciate it more if you have your notebook and pen, including your calculator. So by the time we are moving to this calculation, you are actually not following. You get. So always leave a like and a comment if this video is helpful. It goes a long way to help me to know that yes, what I'm doing here is actually what helping you on the other side watching this content. So what is collision theory all about? Let's say for A plus B, move to what C plus D. Now remember, A plus B reacting to produce C plus D, right? So A and B is what they are what the reactants. Here we have what the product. Now before A and B can actually react to produce C and D, there are some certain conditions A and B must meet. Like there's a certain condition they must attain before a reaction can what take place. You get. Now one of the conditions is what they must collide. Do you get that? There must be what a collision between what the reacting species. They must collide. Do you get that? Do you get that? There must be a collision between what the reacting species. If there is no collision, then the reaction will not what take place. You get. Two. Where's two? Two, they will not just collide, but they must collide with the proper orientation. Now what does it mean? Now not all collision leads to reaction. It's only those that collide with proper orientation leads to reaction. You get. So that is why for out of all the collision, just few collision leads to reaction. There are some that are not oriented very well. Those ones do not produce what reaction. Do you get that? It's only those that are oriented with properly what leads to reaction. So this is what we call effective collision when they are oriented in what in the proper way. You get. That was number two. Number three, they must have enough energy. Now, one thing is to collide. One thing is to what have the proper energy to what break that point where the reaction will take place. You get. So now before a reaction will take place here, now let me say A plus B. Now before a reaction will move towards to the product C plus D, there's always a point between a state between the reactant and the product. So in the sense that A plus B must have enough energy to get to this point before proceeding towards C and D. And this one is called the transition state. Transition state. You get that? Now, in the energy driver, you call this one about activated complex. You get that? So before the reaction must take place, now the reactor must possess enough energy to get towards or to pass this transition state or activated complex before a reaction will form or before the product will form. Do you get that? So these are the three criteria or conditions every reaction must pass through before a reaction will take place. There is everything about collision theory and the reaction required. Now when you have the potential what energy and the reaction. Yes. So here we have a product, sorry, reactant moving the here we have forget what to product. So here we have the reactant. Sorry, so small. Reactant. Here we have what the product. Now what does it mean? It means that for a reaction to take place, now the reactant must pass through a point, must reach a height. Now this height is known as what? The transition was state. What's now what? Activated complex. You get? Now it must get to what? This point first. Now by the time you get to this point before the reaction will take place, so it must overcome this point, this energy here. You get? So now the difference between this guy and the reactant, the difference between this activated complex and the reactant is known as what? My EA, activation what? Energy. You get? Activation energy is what? Is the minimum amount of energy in which what reactant will possess for a reaction to what? To take place. So the energy you need to get to this threshold state or activated complex called what? The activation what? Energy. If the reactant does not possess enough activation energy, there is no way the reaction what will occur. Yes. So the reactant must possess enough activation energy to what? Pass through the transition state before what a product will be formed. Okay. So another thing I really want you to understand is this: that the difference between the product and the reactant, the energy, is called what? Delta what? H. So we call enthalpy. Is the difference between the product and the reactant. So you can see that delta H equals what? Product minus what? Minus what? Reactant. Do you understand? So it's very important you understand this stuff here. So this is called what? The energy diagram what? Profile. Energy diagram profile. And from this place here, delta H can be a positive and can be what? A negative. That's why we have exothermic reaction and what? Endothermic what? Reaction. Look at what Arrhenius what? Equation. Now in Arrhenius equation, we have a relationship K with what? The rate constant equals to what? A E this what? Minus E A what? RT. Yes. You really want to what? Formalize yourself with this Arrhenius what? Equation. Arrhenius equation relates what? K with what? With the activation what? Energy. K equals to what? Rate constant. Right there. A equals to what? Collision frequency. Right there. Collision frequency means what? The rate at which they what? Like the frequency the react and they collide. I know what? Per seconds. Then E equals to what? Activation energy. E is equals to activation energy. R equals to what? The gas constant. It's okay, gas constant, but it's going to be what? 8.314 joules per mole per watt Kelvin. Now the reason why I use this one here, remember in gas laws we have called 0.0821 atm liter per mole per watt Kelvin. So we are not using this one here. And the main reason why I'm using 8.314 joules per mole per Kelvin, you actually tell about what activation what energy, so it involves energy. So that's why we are using this one. Because what? Temperature. Temperature is what? Key. Now, another thing I want to explain here is that now we have two factors that affect the rate of reaction. You get? So we have what? Temperature and what? The concentration. You get? Now, when a temperature is increased, then the kinetic energy of those molecules increases, which leads to what? More collision. The more the collision, the more what? The rate of the what? Reaction. Do you get that? So temperature plays a very great part in what? Rate of what? Reaction. Then the other thing is what? Is concentration. An increase in concentration will cause what? More more of it, or more of the reactant are available. Now, the more of the reactant available, the more the what collision, the more what the rate of what of the reaction. Do you get that? Then when we talk about catalyst, catalyst just reduce the what the activation energy. You get? So these are stuff you really want to put in mind. Now, but before you can solve questions, you need to what know two main formulas. So these are the two main formulas you need in what solving a question. In other words, Arrhenius equation and what activation what energy. Now the first one is when one temperature is being given to us in the what question. It's going to be log K equals to what minus EA, which is the activation energy, all about 2.303 RT plus log A. A is already what the collision frequency. R is always what the gas constant. So R is always what constant. Then T will be what the temperature given to us. Then K is what is the rate constant. You get? So you use when one temperature is being given to you in the question. Now, when two temperatures be given to you, you know that you are going to have two rate constants. You get? So here we have K2 and K1, T1 and T2. So K1 we have what T1. So at the initial temperature, look at what your rate constant, and at the final temperature, look at your what your rate constant. You get? So you are going to use log K2 over K1 equals to EA over 2.303 R. Then you have T2 minus T1 over T1 times T2. Now these two equations is being derived from this point here. You get? So I don't want to go through the stress of explaining how it's being derived, because most times you will not be asked except it's in an advanced exam. But at the beginning stage, you don't need to derive anything. So what you really want to do is to what master what this equation here, or this formula. When the question is being given to you, you should what know where to apply it. So this way I'm going to walk you through some questions you can use to know the one to use to get that. So this way I want you to actually get your calculator ready, because we'll be doing the calculation together. So let's move into the calculation. So now let's take our first question. So what you want to do here is to pause the video, then copy this one inside here what you know. So I'm going to walk you through how to solve this question here. So go ahead, pause this video, then copy this question down. Okay, now let's do it together. Now you see that the energy of activation for a reaction is what 105 kilojoules per watt per mole. So let's write down what the parameter is given to me first. So here we have E equals to 105 kilojoules per watt per mole, right? So remember, kilojoules is also K, which is called kilo. It doesn't descend at what 10 raised to the power 3. So it's going to be 105 times 10 to the power 3 joules per mole. Now it's very important you convert this kilojoules to joules by multiply by what 1000. Do you get that? So there we have 105 exponential what 3 joules per watt mole. Now calculate the specific reaction rate for the reaction at 300 Kelvin. So now they're asking us to calculate what the K of the reaction. Now the temperature given to me is what 300 Kelvin. Right? Now the frequency factor was given to me A, which is what 2.5 exponential 15 watts per second. So these are all the data given to me. It means that I want to use now, because it involves only one temperature, I want to use the formula that involves only one temperature, which is log K equals to what? EA what? 2.303 RT, right? Plus log what? A. So what you really want to do is to substitute what your value. Remember, this is what you are looking for, right? So going to be log K equals to EA is what? 105 exponential what? 3. So we should ignore the unit first. Here we are over what? 2.303 times. Remember, R over here is a gas constant, which is what? 8.314 joules per mole per watt Kelvin, right? So going to be 8.314 times. My T is what? 300 plus log A is what? 2.5 exponential what? 15. 2.5 exponential what? 15. So what you really want to do here, so grab your calculator and evaluate this one. Log K equals to, the other option is going to give me what? 18.2795. It's okay. Then plus log 2.5 exponential what? 15. So we have log so you have plus 15.3974. So that's what we have there. So you sum it also together. Log K equals to now 33.669. So what I want to do here, remember we are looking for K. Divide both sides by what? Log. So if you divide both sides by log, you will have K equals to what? 33.66769 over what? Log. Now this one can also be written as K equals to 1 what? Log times 33.6769. So 1 log you also know log inverse. So we will K. We call the antilog. Log inverse you also know antilog. So antilog 33.6769. K equals to 47.5 exponential what? 32. What is the unit here? So we are going to use the great constant unit for what? Second, first that we actually call per seconds. Per second. So this is the what? Answer. You get this is the answer. So this is how to evaluate when you have one temperature. You get question 2. Let's look at what question 2. The reaction energy of a reaction was found to be, the activation energy of a reaction was found to be 52.04 kilojoules per mole. So my EA equals to what? 52.04 kilojoules per watt per mole. Remember, you have to convert this kilojoules to what? To joules by multiplying by 1000, which is going to give me 52.04 exponential what? 3, right? 3 joules per watt per mole. Now, the rate constant at 40 degrees centigrade, you get that? So here we have K, which is what? K1. K1 is what? 5.76 exponential what? Minus 3. Here we have mole per liter per seconds, right? So my T1 is this, so my K1 is this, then my T1 is that temperature, then which what? 40 degrees centigrade. Remember, I will use calculator. Remember, you have to convert this one to Kelvin. So we're going to be 40 plus 273. So you have to punch your calculator and get the answer. So here we have 40 plus 273. Here we have 313 Kelvin, right? Now say calculate the rate constant, so which is what? K2, which you are looking for, right? So then my T2 is going to be what? 55 degrees centigrade. Of course, I'm still going to convert to Kelvin, which is going to be 55 plus 273. 328 what? Kelvin. Do you get that? So these are our parameters. Remember, my rate constant equals to 8.314 joules per mole out Kelvin. So which one are we going to use? We are going to use formula that relates to what? To temperature. Log K2 or what? K1 equals to what? EA about 2.303 RO. T2 minus T1 or what? T1 times T2. So this is what you really want. This is what you are using here. Remember, we're only for K2, right? So here we have, let's demarcate here so you won't miss point. So here we have log K2. Well, K1 was going to be 5.76 exponential minus 3. So it will be 5.76 exponential minus what? 3. Right? Is okay. Equals to my EA is what? EA give it to me is what? If you have 52.04 exponential 3 over what? If you have 2.303 times 8.314, right? Then we have this one here. T2 is what? T2 is what? 328 minus T1 is what? 313 over multiply them. So 313 times 328. Please, when you are solving, you need to what? Take what step by step. Do that so that you are not going to what? Make mistake. Remember, nobody is what is chasing you or pushing you. So you have to what? Take your time to actually what to get the answer. So what I want to do now you leave it like this, then I want to evaluate all of this one here. You get? So I want to evaluate this one. So we have log K2 what 5.76 exponential what minus 2. So evaluate all of this one here. So what you really want to do, so you have to calculate here and evaluate this one. You get? So if you evaluate that one 52.04 exponential 3 divided by we have 2.303 times 8.214. Here we have 2717.899 times. Then the other of this one here, we have 328 minus 313 divided by 313 times 328. So you have 1.46 exponential minus 4. Yes. So what you want to do is to multiply 2 of them. Log K2 what 5.76 exponential minus 3 equals to what? 0.3971. So what you want to do now is to what? Take the inverse log of both sides. You should divide both sides by log. Here, this log is going to go out there. You have to have what? The reverse log, which you call anti-log. So you divide both sides by one log here. You have K2 or what? 5.76 exponential what? Minus 2 equals to, so we should call log inverse. It's okay, here you can also say anti-log. Log inverse 0.3971. So what you want to do is to punch your calculator 2.4951. So you have K2 about 5.76 exponential minus 3. So what you want to do is to cross multiply. And when you cross multiply, what you have 2 equals to 5.76 exponential minus 3 times 2.4951 0.014 So what is in the unit is going to be the initial of this one per liter per what second. So this is what answer. Get. So we have come to the end of this video. What you really want to do now is to what? Go into your past question, then try to what? Look for similar what questions. Then you tackle those questions yourself. You get. If this video is helpful, please give it a like and comment what you think about this video. If this video is helpful, I really want to hear from you. Just say helpful, this video is helpful. That one will tell me to know that you watching this video on the other side is actually what gaining value from this what content you get. You can also share this video to your friends and your classmates so they can also what learn from the channel too. People of this channel is to what make things much easier for you in your personal study. Yes, so that is the main reason why this channel is what is created. Yes. So if you are not subscribed to the channel, please hit the subscribe button and turn on the notification bell. And always give this video a thumbs up, a like, so I can what help to spread to other persons that need this kind of what content. So see you in the next video. There's a video there. Maybe you can check most of the video you would like to watch. So go and check it out. See you in the next video.